Why do we need switches? That's a very valid question. And a lot of people don't really understand why we need switches. So, in order to help you understand why we need switches, let me tell you about this product right here. This product we find in the middle is called a hub. That's right, it's a hub. What is a hub? A hub is a predecessor to switches. Yes, hubs existed before switches. What is the purpose of a hub? A hub has multiple ports that allow us to plug multiple devices into it. So here in this case, you can see this hub is connected to a router, two PCs, and a server. Hubs allowed us to interconnect all those different devices together that we needed to interconnect together in our organizations. They worked well for a short period of time until we demanded better networking speeds, better communication. And then the hubs really didn't provide the necessary resources that we need to accomplish our goals. And here's the reason why we can see the collision is happening. What is the collision? Well, a collision is going to occur inside of a collision domain. And a collision domain is the portion of your network where two or more frames can collide. In this particular scenario, you can see that we have one large collision domain. Both our PCs, our router, and our server are all part of the exact same collision domain. One large collision domain. As a result of that, anytime any of these devices communicate, we could have a collision occur. Doesn't necessarily mean the collision is going to occur on the hub. The collision could occur on the link between a hub and a server. Why is the collision happening? Because when we used hubs, we were only able to operate in what is known as half duplex. Half duplex means we can only send or receive at any given time. Well, in this particular case, everybody's sending in my scenario, which means that nobody can receive, right? You can only send or receive at any given time. So since everybody's sending, are these frames going to collide in this collision domain? Yes, that's exactly what's going to happen. And we can see that occurring right here. The frames are colliding. So since it's half duplex and you can only send or receive at any given time, if more than one device sends out a frame, we have a collision. That's a guarantee. Now, the data link layer of the OSI model is where we identify the rules of communication. So when we're operating in half duplex, the rule is you use carrier sense multiple access with collision detection, CSMACD, carrier sense multiple access with collision detection. So what that implies is that we are going to listen to the network. And we are going to wait for the perfect time to send our frame. And when that time arrives, we're going to send it. If no collision happens, great. Everything worked out as it should. But if a collision does happen, the collision detection part of carrier sense multiple access collision detection is going to kick in. And everybody backs off. That's right. Everybody backs off and says, all right, I'm going to turn on a random timer. Once my random timer expires, the network should be cleaned up because nobody's been talking while this random timer is on. And then I'll go ahead and start communicating. And if everybody did well, we shouldn't have a collision again for a little bit of time. So the problem with half duplex networks is that since you can only send or receive at any given time, there's quite a few collisions. And in today's day and age, collisions are bad. If you're having a phone call, voice over IP, or you are having a video conference, collisions are going to make your communication absolutely impossible, voice and video wise. So we don't use hubs today because they don't work well in our real-time application deployment. We want full duplex environments. So to get a full duplex environment, we introduce a switch. So our switches are now going to introduce multiple collision domains. Notice how every single device is in its own collision domain, including this router. This router connected to the switch is going to be in its own collision domain. It really is. Every single port on a switch is in its very own collision domain. It is. Wow. Yeah, wow. Impressive, isn't it? It really is. So the result of that is that we are now operating in full duplex. We can receive and send data at the exact same time. That means everybody can talk whenever they want to talk. We don't have to follow the CSMA CD rule now. In actuality, when we use switches, the CSMA CD rule, if we're operating in full duplex, is disabled because we don't need it anymore. We can send and receive at any given time we want. No collisions. Could we still have a collision between the switch and the PCs and the server? Yeah, we could, because it's still a collision domain. But the chances of the switch sending while the PC or server is sending at the exact same time is next to none. It's not going to happen. It's not going to happen. Why? Because of these very small, tiny, independent collision domains that we have. So if I have a 24-port switch, I'm going to have 24 collision domains. In this case, I have a 4-port switch that's in operation right now. So we have 4 collision domains. We don't see the collision domain between the switch and the router, but we would have a collision domain there as well. We definitely would.